In this video, we're going to look into an analogy for propositions, which are switching networks. So, what is a switching network? A switching network consists of wires and switches that can open and close. They are used in many electrical appliances, telephone equipment, and computers. So, we're going to use a switching network. Here's a simple illustration as an analogy for propositions. So we have here this very simple switching network diagram, and we have here A and B, as you can see, this A and B here, this one and this one here. We call them terminals. So this is one terminal, and this is another terminal, which we can also draw as a simple dot. So I can draw it like this, then P, then another dot here. So this P here is this is our switch. And it's the common notion of a switch. However, we have to take note of the following. So, if P is closed, then the electric current can flow from one terminal to another. The network is said to be closed if this happens. Now, again, we have to take note of that. If P is closed, then the electric current can flow from one terminal to another. Remember, we have a common notion. We have a common notion that if we open the switch, then the device is running and the device is open, which means current is flowing and all that. However, we are talking about switching theory, which is the theoretical study of, a switching network. So we have to take note that if P is closed, then the electric current can flow. So this is not our usual open and close wherein if it's closed, the current is not flowing, hence it's not the device or the appliance is not working. Here, if it's closed, then electric current can flow. Similarly, or let's say in relation to that, if P is open, then the electric current cannot flow from one terminal to another, and it is said that the network is open if this happens. So unlike the common notion that we wrote in, we forgot another N here. There you go. We shall follow what switching theory tells us, that if the switch is closed, that means current can flow. Current flows, and which would mean that the device, the appliance, is working. While if it's open, then current does not flow. This is what we will follow. And later on, these will be important as we determine when is the entire network open and closed. Now, let's take a look into parallel and series circuits. So the figure below shows two switches, P and Q, connected in series. So we have here our two terminals here. Here are our two terminals. And we have switch P and switch Q. According to this one, the series network is closed if both switches are closed. So if both are closed, then that's the only time the entire network is closed. So based on that, if both are closed, which do you think is a proposition that is analogous rather to this specific network? So if you thought of the conjunction P and, there you go, P and Q, then you are correct. So if the network is a series circuit or a series network, we can somehow liken it to a conjunction. On the other hand, we have here two switches that are parallel. So this is what parallel looks like. And this parallel network is closed if either P or Q is closed. So in the series network here, if both switches are closed, while here in parallel, either P or Q is closed. So based on that, which proposition do you think is analogous to a parallel circuit? So if you thought of P or Q, then you are correct. So a parallel network is analogous to the propositional form P or Q. Alright, so bearing that in mind, again, we have to take note that these are the ways rather how we can make an analogy between our networks and our propositions. So if we have a series, let's write it here. If we have a series network, then we can say that this is analogous to a conjunction. Conjunction. On the other hand, if we have a parallel, which is P or Q, then this is a disjunction. So there you go. And of course, we also have a switch that is not P. If we have a switch P, then we will also have a switch that is not P. And this will be helpful once we analyze switching network through our propositions. And that's what we will do in our next video.